Let's talk about analyzing RC series circuits using differential equations. Suppose we have a simple electric circuit with a voltage source, a resistor, and a capacitor. Again, the resistor and the capacitor, that's why we call it an RC series circuit. Capacitor stores energy by building up an electric field. Suppose the voltage at the voltage source is epsilon volts, the resistance is R ohms, the capacitance is C farads, and the charge at the capacitor at time t is Q of t coulombs. Then dq dt equals epsilon c minus q all over RC. I see a differential equation. Let's see if we can solve that. For example, a 100 volt electromotive force, EMF, is applied to an RC series circuit with a resistance of 400 ohms and a capacitance of 10 to the negative fourth farad, that is 1/10,000th of a farad. A, find the charge Q of t on the capacitor if Q of 0 equals 0. Okay, let's set up our differential equation. dq dt equals epsilon c minus q over rc. Epsilon is 100. Capacitance c, 10 to the negative fourth. We're going to leave the q as it is. The resistance R, 400. Capacitance, again, 10 to the negative 4. 100 times 10 to the negative 4, that's going to be 0.01. And 400 times 10 to the negative 4, that's 0.04. So this is what we end up with. This is a separable differential equation. So let's get the q's on one side. We have dq over 0.01 minus q when we get this stuff on the other side. And when we get the dt on the other side, the right side is just going to be 1 over 0.04 dt. In other words, 25 dt. So we have dq over 25, dq over q minus 0.01 equals negative 25 dt. Again, we're just multiplying both sides by negative 1, so we have q minus 0.01. There's our differential equation. Let's integrate. And the antiderivative of the left side is just going to be the natural log of the absolute value of q minus 0.01. That equals negative 25t plus c. Now again, remember q starts off as 0, so q minus 0.01, that's going to be negative. So the absolute value of q minus 0.01, that's not going to be q minus 0.01. The absolute value of q minus 0.01 is 0.01 minus q, and that again is because q starts off small. Q starts off at 0, and truth be told, it actually goes from 0 up to 0.01. So again, q minus 0.01 is negative, so when you take the natural log of the absolute value of that, you just get natural log of 0.01 minus q. We know what to do. To get q all by itself, we exponentiate both sides, so we raise e to both sides. We get e to the natural log of 0.01 minus q equals e to the negative 25t plus c. That is e to the negative 25t times e to the c. Okay? And now we can rewrite all of this stuff. E to the natural log 0.01 minus q. That's just 0.01 minus q, because e to the x and natural log x are inverses of each other. And we can also rewrite the right side. E to the negative 25t, okay, that's e to the negative 25t. E to the c, c is just a constant. So if it's just a generic constant, we're going to write that it's just plain c. Let's move the 0.01 to the other side. And we have negative q equals negative 0.01 plus c e to the negative 25t. Multiplying both sides by negative 1, we get q equals 0.01 minus c e to the negative 25t. Again, c is just a constant, so we're just going to write negative c as just plain c. So q of t equals 0.01 plus c e to the negative 25t. Let's plug in our initial value. Plug in t equals 0. We have q of 0 equals 0.01 plus c e to the negative 25 times 0. That's in other words 0.01 plus c e to the 0. We already know what q of 0 is. Q of 0 is just plain 0. And c e to the 0, that's just plain c. So we have 0 equals 0.01 plus c. Move the 0.01 to the other side, and we find that c equals negative 0.01. So if c equals negative 0.01, we can plug that into our formula for q of t, and we end up with q of t equals 0.01 minus 0.01 times e to the negative 25t. Find the current, I of t. Okay? Turns out that the current is just the derivative of q, the charge. So I of t is going to be dq dt which is the derivative of 0.01 minus 0.01 e to the negative 25t. This is pretty easy to figure out. Derivative of 0.01, that's 0. And the derivative of this expression, you're going to get negative 25 times negative 0.01 times e to the negative 25t. In other words, it's just going to be 0.25 times e to the negative 25t. By the way, speaking of electricity, I should say, electric eels stun their prey by delivering up to 880 volts of electricity. In fact, the anatomy of the electric eel inspired the design of the first battery. This was by the Italian scientist Alessandro Volta in 1799.